Hey guys, welcome back again to another edition in geometry. Mr. Anderson here with you in chapter 11 now. So we're going to do section 1 in chapter 11. We'll talk about the area of parallelograms and triangles. And we've talked a little bit about parallelograms and triangles before, but we'll talk about the area of those things today. So first of all, we'll find the perimeters and areas of parallelograms and also perimeters and areas of triangles. Some of this might be a little old hat to you, so to speak. So hopefully this won't be too bad today. All right, first of all, the area of a region is the sum of the areas of its non-overlapping parts. All right, I think what they're getting at here is this. If you look, we're going to try to find the area of this parallelogram, and here's kind of how you can relate it back to stuff that we know before. If I start right here at this corner, I'm going to draw a line straight down at a 90-degree angle. And this triangle here that's formed, I'm going to take that triangle and I'm going to move it over to this side and put it over here. Whoops. Whew. Okay, I can't quite draw a straight line there. For whatever reason, every time I get to that one spot, it keeps dipping. There we go. Wow. All right, so what we've done is we've gotten rid of this over here and added over here. Well, now what does that look like? That looks like a rectangle, doesn't it? That's a rectangle. And we know from past experience that the area of a rectangle is just the length times the width. And so if we're thinking about a rectangle there, the length times the width would just be, length would be this side here, the width would be up and down. Well, so what we've done here is we've just created, we cut up our parallelogram a little bit here and created a rectangle. And so if you notice here, the part, this is B, which stands for base. And actually, if you remember, like in a parallelogram, this side, this base, would be the same as this side up here, and these two would be the same as well. So in this case, we cut off part of the base, but we added over here. So it's still the same B, it's still base, and the height, what we're calling height now, is the same as the width. So really, it's just the same as a rectangle. We just use different terms here, but the area, instead of length times width, we just call it base times height. But it's really the same thing. It's just this side and the height there, okay? So area is the base times the height. And you might have known that already, but that's why it works that way. So let's look at a few examples. All right, first of all, find the perimeter. Remember, the perimeter is the distance all the way around the outside. And so we can just count it up. Well, what do we know here? Well, we know, let's see, where's my here it is. We know that 20, we have 20 inches on this side, and as I said before, in a parallelogram, the opposite sides, remember, are not only parallel, but they're also equal to each other. They're also congruent. So this side over here would also be 20. And this is 32. They tell us that this little part here is 12, but since this is 32, that means this whole thing here is 32. And so to find the perimeter, all we'd have to do is add those up. We've got 20 plus 20 plus 32 plus 32. So it'd be 40 and 62 or 64, so that'd be 104 inches. Okay, so there's the perimeter. Easy. All right. Well, next, this is what we just talked about, was the area. Remember, the area is the base times the height. So the base times the height. Well, we know that the base is 32, and they've drawn a little height thing in here for us to help us out. But guess what? We don't know what it is. Okay, so this throws us a little dilemma here. What could we do with this? Or how could we find out what that is? Well, if you look closely here, and hopefully by now you're starting to look for these things, we've made a triangle. And this triangle has a 90-degree angle in it. And we've done this a few times before. So if we have a triangle that's a right triangle, we can do the Pythagorean theorem. Remember that? A squared plus b squared equals c squared. And so that's what we can do here. Because we know this side is 12 and this side is 20, so we can find the third side. So remember, I'm going to do this maybe kind of over here. So remember, the key thing is you have to figure out which one is C. All right, so remember, since this is marked as 90 degrees here, that means this angle on the other side is also going to be 90. Wow, that's 90. And so then remember, straight across from the 90, that tells you what the hypotenuse is, which is C. So the 20 is the C here. Man, I just don't have much time at all on this today. And the other two can be interchangeable, so we could just call, we'll call it H for height, since that we're trying to find, what we're trying to find. And then the other one is 12. Okay, so what we're doing is we're calling this H for height. Okay, so let's work it out. H squared plus 144 equals 400. And we'll subtract 144. And so we've got H squared. Here we go. So we've got 400 minus 144, 256. And then we'll take the square root. So second function, square root, should be right there, square root of 256. And that tells me 16, so the height is 16. And so now in order to find our area here, all we do is plug it in over here. The area is the base, 32 times 16. And then I guess I could have left that up. 32 times 16 would be 512. So the area is 512. And since it's area, remember that's in square units, so inches squared. Okay? Now one other thing, let me just mention this briefly here. You know, when we were doing our triangle here, we did the Pythagorean theorem. I wanted to show you that because no matter what the numbers are over here, you can follow that step. But always be aware and pay attention to the possibility of Pythagorean triples as well. And remember how we looked at that before? We said if I had 12 and 20, I said, well, what could I divide them both by? Well, if I divide 20 by, if I divided 20 by 4, that would give me 5, right? And if I took 12 and I divide it by 4, I would get 3. So this side is 3, this is 5. And remember the hypotenuse would have to be the longest one, which is 5. Remember that Pythagorean triple, 3, 4, 5. So if this was 3, 4, 5, if it was that ratio, and then since we had divided by 4, you just multiply by 4 to get from 4 back up to 16 here. So so that is a thing to be aware of as well. All right, find the area. In this case, we're not going to find the perimeter. We're just going to find the area. Now, this is kind of fun, okay, because look what we've got. We have a 45-degree angle here. We know the whole length of this is 12. We know this side's 9. And it's kind of similar. Well, I mean, in one sense, you think, hey, this might be similar to what we just did. But the difference is we know that this side would be 9 because this is 9. We're trying to find the height, but we don't know what this distance is here, do we? We don't have enough information to do the Pythagorean theorem, or Pythagorean theorem. So what can we do? Well, the fun thing here is, notice that this is a 45-degree angle. And since this is 90, that means this side would also be 90. And so that means, oh, well, this has to be 45. So we've got a 45, 45, 90 triangle. Hey, all right. So remember, there was a pattern for those triangles, the 45, 45, 90 triangles. Remember what we did there? It was L, L. The two legs are the same, and the hypotenuse was L squared of 2. So in this case, this is a leg and this is a leg. They're the same, even though it doesn't look like it there. And then this is L squared of 2. So the number 9 took L and multiplied it by square root of 2 to get to 9. So what do we have to do to kind of get that square root of 2 back out to get back to this L? We have to divide by the square root of 2. So what we have to do here is we have to take 9 divided by the square root of 2, which will tell us what our leg is here. And so let's see what that's going to be approximately. Remember, a lot of times we would try to get rid of the square root of 2 on the bottom of a fraction and work that out. In this case, we're putting it into a formula, so I'm not going to worry about that. I'm just going to plug it into my calculator here. So I'm going to go 9 divided by the square root of 2. I'm just going to get a decimal here. So that's approximately 6.36. So it's approximately 6.36. And so what we're going to do then is we're going to plug this into our formula here. So the area would be the base 12 times about 6.36. And what I'm going to do is since this we had rounded that to 6.36, I'm just going to leave this original number in here and just take that and multiply by 12 so I'm more precise with it. And I get 76.37, we'll call it. 76.37, and as a matter of fact, there's no units on this one, so we'll just say units squared. Okay, so that's something to remember. Remember those special right triangles, the 30, 60, 90, and the 45, 45, 90. They can come in handy at times as well. All right, triangles. This is one you should all be pretty familiar with. This is kind of one of those that's very popular. Area equals 1/2 base times height. If you want to, you could think about it base times height divided by 2. That would also work. I think most people remember this one. And just remember kind of where that comes from is if you had a rectangle. Remember we were just talking about that? You know, if you called this the base and this the height, and you cut it in half, what do you have? A triangle. So therefore, you take the base times the height and take 1/2 of it, or divide it by 2. So that's where we get that formula from. All right, now, of course, I can't give you like a nice simple one to start with here, but a lot of times you're going to see, it'll be marked out really easily for you. Occasionally you get a triangle like this where the height is actually outside of the triangle. The 9 is going to be the height here, and the 12 is still the base. So in this case, the height is outside of the triangle. A lot of times it would be drawn inside the triangle. Like if you had a triangle, like this, that would be your height. Okay, that would be your height there. But most of the time that's your height, and this is your base. But in this case, it's drawn outside. So I wanted to do one like this because a lot of times people have questions on this kind. Hey, what do I do? Well, here's what you do. So our area is 1/2 base times height. We already know the base here is 12. And the height, well, that's 9. And so, like I said, again, this stuff doesn't really matter here. It's just the base is 12, the height is 9, as far as the area goes. And then when we multiply this all together, really 1/2 of 12 is 6. So it's really just 6 times 9, which is 54. Again, there's no units on this, so we'll just say units squared. And then in this case, it did also ask for the perimeter. And so in this case, the perimeters just add these up, 16, 12, and 7.5. And so that would just be what, 28, 35.5 units. Okay, So there's perimeter and area of that triangle. All right, last one. We'll make this one a little fun and tough here. The height of a triangle is 7 inches more than its base. The area is 60 square inches. Find the base and height. Well, let's see what we got here. Let's just draw an example. I'm going to draw one back to kind of like the normal kind like we might see here. So here's our triangle. Here's going to be the height. And it says, what does it say here? The triangle is 7 inches more than its base. The height is 7 inches more. So if we call the base, I will call the base B, just for the heck of it, because it's a base. That means the height will be B plus 7, right? Does that make sense? So if B is the base, and it said the height is 7 inches more than its base, the height would be called B plus 7. All right, well, what's our area formula here again? Remember, area is 1/2 base times height. Well, do we know the area? Hey, it told us that the area is 60 square inches, so let's plug in 60 for area. The B, well, that's our B, and the height is B plus 7. There we go. What I'm going to do here is this. Before I multiply this, since this is 1/2 times B plus 7, I'm going to, and I'll show you why to get rid of this fraction here. I'm going to multiply by 2/1 and 2/1. That way this 2 will cancel that 2 out. And over here, 2 times 60 is what? 120. Now do you see how that's going to be a little bit nicer? A little bit easier to deal with instead of that 1/2. Now let's distribute that B. So B squared plus 7B is 120. Whoa, we got a B squared. Okay, hey, guess what? Remember Algebra 1, we had to do some factoring? Uh-oh, factoring. What we're going to do here is, if this is a good review from Algebra 1 here, we're going to get all the terms on the same side. So I'm going to subtract 120. So now I've got B squared plus 7B minus 120 equals 0. Okay, so what we're using here is the zero product property. This is 120 here. All right, if you remember, when we factor this down, it's going to factor down into 2 parentheses. Since we don't have a number in front of the B squared, the only way it could break down is B and B. B times B is the only way we can get B squared. And to figure out these 2 numbers that are going to go in here, remember what we have to do is we look at this number here and we say 120. I have to figure out what 2 numbers will multiply together to be 120, but add up to be 7. And as a matter of fact, probably would have gone quicker if I would have looked at this ahead of time to know exactly what that's going to be. But we'll figure it out here in a second. If I can turn my calculator on. All right, so let's just try a few things here. I've got 120. If I divide that by say 10, which I didn't mean to do that to one. Sometimes this calculator, it does not respond very well to me. So if we divide by 10, what do we get? 10 and 12, right? I'll move this over here, I think. 10 and 12. Okay, well, if we add those together, well, now also keep in mind here is when we multiply, since we're trying to get a negative 120, I should have put here, that means that one of these has to be negative and one has to be positive to multiply together to be a negative 20, right? So if I make this a negative 10 and a positive 12, that's going to give me 2. Okay, so that's not quite there. I've got to try a little bit more. So what I'm going to do is here when I'm going to go, let's see, 120 divided by, let's try 9. Nope. Man. What if we go divide by 8? 8 and 15. So remember, one has to be positive, one is negative. So I'm going to call this a negative 8 and a positive 15. Now, guess what? 15 and a negative 8 is 7. So in this case, then, these are the numbers we're going to use. We can plug them directly into our equation there. So I've got b minus 8 times b plus 15 equals 0. And remember, in order to get 0, that means either this parentheses has to equal 0 or this parentheses has to equal 0. And so what are the two things that could happen? What could make this parentheses 0 if b was 8? And what would happen if, to make this parentheses 0, b would have to equal a negative 15? Okay, so what are we trying to do here again? We're trying to find the base and the height. And so can we have, on a triangle, can we have a negative distance? No. So that means there's two possible answers mathematically, but in reality, we cannot use a negative distance here. We can't say it's a negative 15 inches long. 8 is the only answer here. And so in this case, then, our base would be 8 inches. And our height would be what? 8 plus 7. So our height would be 15 inches. And as a matter of fact, I'm not sure. I'd have to look at this more in depth. But this may or may not be a coincidence that our height is 15 and we had gotten a negative 15 here. I'm not really sure about that. So that may not happen every time. I'd have to check that out to make sure. Okay, well, that's it. Kind of a fun one to end on there. Appreciate you being with me here in 11.1. I'll see you again in 11.2. We'll talk some more about areas of different figures. See you then. Bye.